Hey guys, in this video I am going to teach you how to solve quadratic application problems that involve finding maximum height. So to find maximum height, remember with a quadratic, it's just a U-shaped graph. So that means that you're going to have a vertex that is a maximum. So essentially that's what we're looking for, the vertex of your maximum. So we're going to use the formula that we used before, opposite of b over 2a to find the x value, and then we would plug it back in to find the y. The x value would tell you how long it takes to get to the maximum height, and the y value would tell you what the maximum height actually is. So let's try that in a couple of problems. A bottlenose dolphin jumps out of the water. The path of the dolphin traveled can be modeled by the equation right here, where h of d represents the height of the dolphin in feet and d represents the horizontal distance in feet, so how far across the dolphin has gone. We want to find the maximum height the dolphin reaches. So sometimes it can be helpful to sketch a picture for this. So that's what we're going to do first. So if I sketch a picture, first of all, I'm not a great drawer, so just bear with me here. If this is the water that the dolphin is jumping out of, we know that at some point the dolphin started in the water, and at some point the dolphin is going to land back in the water once again. So the path that the dolphin travels is U-shaped, like a quadratic. Now, I'm going to draw a fish here, even though a fish is not a dolphin, but we'll just pretend that this here is a dolphin. If I try to draw a dolphin, it ends up looking like an airplane or something, so we're just going to pretend that that's a dolphin. So we're trying to find the maximum height that this dolphin will reach. Now we know that if we find the x value of the vertex here, it will give us the horizontal distance that the dolphin has traveled. And then we plug that back in, we will get the maximum height that the dolphin reaches at that horizontal distance. So that's what we're going to find. So going back to our equation, we know that a is negative 0.2, and we know that b is 2. So if I plug that into my formula, I have x equals the opposite of b, which is negative 2, over 2 times negative 0.2. Well, let's figure out what that horizontal distance is. So negative 2 over 2 times negative 0.2 is 5. So that means that the dolphin has traveled a distance of 5 feet when it reaches its maximum height. Now let's plug that back in to find out how high the dolphin is at that moment in time. So y, or in this case it's h of d, you can write it either way, equals negative 0.2 times 5 squared plus 2 times 5. And once again, I'm just going to plug that straight into my calculator. And I get 5 again, which is unusual. You don't usually get the same thing. But this means that the maximum height the dolphin reaches is 5 feet. All right, let's try one more. It says you throw a basketball whose path can be modeled by y equals negative 16x squared plus 15x plus 6, where x represents the time in seconds and y is the height of the basketball in feet. Once again, what is the maximum height that the basketball reaches? So let's go to a drawing here. This is my hoop. Okay. This is me standing here on the ground, getting ready to make a basket or try to make a basket. And once again, that makes a quadratic because I'm shooting the ball and hopefully it will go into the net. So I'm trying to figure out the maximum height that that basketball reaches. Okay, so a in this case is negative 16. I get that straight from my equation. And b is going to be 15. So the opposite of b is going to be negative 15 over 2 times my a, which is negative 16. Let's take our calculator and figure out what that would be. We get 15 over 32. Let's go ahead and change that to a decimal and make it 0.49. Sorry, 7. So it takes just under half a second for that basketball to reach its maximum height. And if I plug that back into the equation, I will get the maximum height of the basketball. So negative 16 times 0.47 squared plus 15 times 0.47 plus 6. Okay, so let's plug all that in. And you get 9.51. So that means the basketball reaches 9.51 feet. And that's it. That's how you would find the maximum height of any sort of quadratic application.